Good afternoon. I'm Andrew Wheeler, Administrator of the U.S. Environmental Protection Agency. I want to thank you all for joining this event today with EPA and the Girl Scouts. We have 3 EPA scientists here to speak with you about their important work protecting human health and the environment. By viewing today's program, you are also eligible to receive a limited edition EPA 50th anniversary patch. I hope this patch will help remind you of the important role we all play in protecting the environment. I know that you will enjoy hearing from them, and they are looking forward to answering your questions. Before we get started, I wanted to share a little history. Yesterday was the 50th anniversary of the EPA. EPA was created by President Nixon to protect human health and the environment of the American people. Over the past 50 years, we have accomplished many things. We've made our air cleaner so that it is easier to breathe. We've improved water quality so that we can enjoy clean drinking water and spending time on our rivers and lakes. And we have cleaned up our nation's land so that we can safely enjoy spending time outdoors. All of these achievements were made possible by the research and science of our dedicated scientists and engineers. EPA scientists care deeply about the environment and they work to protect it. As Girl Scouts, I know that you care deeply about our environment too. From camping trips to hiking and learning about animal habitats, being a Girl Scout helps you develop a lifelong appreciation for the environment. I am an Eagle Scout. I grew up in Ohio, and Scouting gave me a better appreciation of the environment. I hope that you will take your love for the outdoors and consider a career in environmental protection, maybe even here at the EPA. We are looking forward to each of you being our future environmental leaders. Despite our success over the last 50 years, we still face big challenges. I believe that the leadership skills and love for the environment you are developing as Girl Scouts will prepare you to solve the problems we face today and in the future. I also want to encourage you to consider applying for the President's Environmental Youth Award. This yearly competition, which opens for application each fall, recognizes outstanding environmental projects by youth from kindergarten through 12th grade. And the program promotes awareness of our nation's natural resources and encourages positive community involvement. 2 areas where I know you all excel as Girl Scouts. You can learn how to apply by visiting epa.gov. Thank you for joining this event today. I hope that you wear your new 50th anniversary patch with pride, and I look forward to seeing the impacts that you will make as environmental leaders of the future. Thank you.
Wow, that was great. Hi, everyone. Welcome to Awesome Girls Protect the Planet, a very special event brought to you to celebrate the 50th anniversary of the U.S. Environmental Protection Agency, or the EPA for short. That's a long time. That's 50 years the EPA has been helping to protect our planet and all who inhabit it. That's you and that's me. I'm your host, Darlene Cavalier, and you just heard from Andrew Wheeler. He's the head of the EPA. We want to thank Administrator Wheeler and the EPA for their generous support of our event tonight. We also want to thank all the wonderful staff at the EPA who have helped us with this event, and a special shout out to the Girl Scouts alum and Girl Scouts parents who work at the EPA. We see you and we thank you. Today's event is sign language interpreted by Kiva Bennett and Katie McCavanagh. In a few minutes, you're going to meet 3 amazing environmental scientists from the EPA. They're going to tell you what they do. They're also going to help introduce us to the Think Like a Citizen Scientist journey. Maybe you've already started the journey. Maybe you've already completed the journey. If so, you know that one of the important skills that you did was to make and share observations. That's what our friends from the EPA do every day. They make and share observations and help protect this planet that we love. Now, as Administrator Wheeler mentioned, if you tuned in today, you're eligible to receive a free EPA 50th anniversary patch. You'll need to stay for the entire event and complete a survey at the end in order to get your free patch. And we'll talk a little bit more about that later. We'll go over some of the housekeeping here for the web technology information. I'm gonna read some notes. Pay attention. You joined us today either by computer or through the GoToWebinar app on your device. You'll hear today's program through your computer or on your device, and there's no option to dial in using a phone. If you want to ask our speakers questions during the program, find the questions box on the left side of the screen, right underneath where you see my face. Type your questions there with your first name and the city and state that you're from. Then hit send. You can enter your question at any time during the event, and we'll try to answer as many as we can, especially when we get to the question and answer portion of our event. At any time, you can click on the back tabs you see at the right side of your screen for more information about Girl Scouts and our event partner, the EPA. You'll also find details about how you can get your free Think Like a Citizen Scientist journey and your free EPA patch. If you don't have time to jot down all of this information before the event ends, don't worry. We put it all in a special handout that you can download. You'll find it under Event Resources on the bottom left side of your screen, underneath the question box. That was a lot of information. Okay, once again, I'm Darlene Cavalier, and I'm the founder of SciStarter. I was a Girl Scout brownie in Morrisville, Pennsylvania, and I love dressing up in my brownie outfit to go to meetings with my little sister, Marlene, who was also a brownie. Now, before I introduce you to our guest speakers, I want to quickly share where we're all joining you from today. I'm from Philadelphia, Pennsylvania. Two of our speakers are from Research Triangle Park in North Carolina, and one is joining us from Cincinnati, Ohio. And this is where you're from. We are so thrilled to have girls from all 50 states, including my niece, Allie, who tuned in from Langhorne, Pennsylvania. Hi, Allie. Hi, girls. We also have representation from pretty much all over the world, including Puerto Rico, Guam, China, Dominican Republic, Ecuador, Germany, Hong Kong, Portugal, and more. Now, are you ready to think like a citizen scientist? So am I. And guess what? Our guests from the EPA are here to guide us and to tell us more about their careers and to get us started on the journey. We'll be doing some really fun activities with them too. I'm so excited for you to meet them. Okay, first, I want to introduce Dr. Rebecca Dotter. Rebecca is a physical scientist working in the EPA's Office of Research and Development. She leads the Combustion Source Branch. She'll tell you more about this soon. Have you ever heard the word combustion before? It means the process of burning something. Rebecca and her team investigate how cars and trucks and other vehicles pollute the air. They also look at how pollution is caused by the smoke from stoves and wildfires. Some air pollutants can be hard to measure. They're pretty small. And Rebecca and her team are always looking for new ways to study them. Hi, Rebecca. Thanks for joining us today.
Thanks, Darlene. It's great to be here with you all.
We'll hear more from Rebecca in a moment. Now let me introduce you to Dr. Andrea Clements. Andrea is also a physical scientist in the EPA's Office of Research and Development. Her work focuses on measuring air quality. That means she looks at how clean or polluted the air that we all breathe is. It's a really important job. She's now testing out new devices that will let us test air quality cheaply and in more places. even in our own backyards, meaning we can start to test our own air quality. She wants to understand how these devices work so she can help us use them to keep our environment healthy. Remember, that's the air that we breathe. Hi, Andrea. We're so glad to have you with us today. And did I hear that you're a lifetime Girl Scout too?
That's right, Darlene. I am a lifetime Girl Scout, and I'm so happy to be here with you all today. I joined the Girl Scouts when I was in first grade.
Well, welcome. We're really excited for you to be with us. And finally, let's meet Shannon Griffin. Shannon is a biologist at the EPA. She works in the Center for Public Health and Environmental Assessment, which is also part of the EPA's Office of Research and Development. Shannon's work is focused on community health and well-being. She helps measure how much virus activity is in our water. And she also wants to make it easier to test it in case we've been infected with germs in our environment, like the kind that caused COVID-19. Hi, Shannon. Welcome.
I'm happy to be here. Thanks, Darlene.
Okay, this is going to be fun. Now it's time to have our scientists join us from the EPA. Did you know that you can help with scientific projects no matter what age you are, no matter what degrees you have or do not have, and no matter what you do for a living? That's called being a citizen scientist. Of course, we hope that by becoming citizen scientists, you may someday decide to become a scientist, but you don't have to. That's the beauty of citizen scientists. It's for everyone. Anything you're curious or concerned about, citizen science has a way for you to learn more about that topic. Whether you're a citizen scientist or someone who works as a professional scientist like Rebecca, Andrea, and Shannon, you need really good observation skills. Observation means looking at something very carefully. And today we're going to do 2 activities to practice observation. Have you ever played I Spy? I bet you have. You know that's when somebody sees an object and they have you try to guess what they're seeing. They may give you clues to help figure it out. You have to look around your space really carefully to figure out which object they looked at and which object they spotted. You might even have to ask them for some more clues. Well, today, since we're not all in the same room, what I see in my space may not be the same as what you see in your space. So we're going to play I Spy a little differently. And Rebecca's going to help us.
That's right, Darlene. That's right, Darlene. First, we're going to give you a color. As you can see here, the color is blue. We want you to look around your room and see if you can find or if you can spy something that's the color blue.
When you're done, let us know what you have found by typing it into the question box. Ask an adult for help if you need to, and we're going to give you about 15 seconds.
In the meantime, let's take a look at what our scientists found in their rooms. Andrea, what blue object did you find?
Well, I found this magnet, which has a lot of blue in it, and it's from Grand Teton National Park.
Super cool. How about you, Rebecca and Shannon?
I have my water glass, and my water glass is blue.
And I spied my blue shirt, and I also have a blue pen sitting at my desk.
Okay, well, I'm taking a look at what others have found. Share it with us. Okay, we see somebody found a blue library card, a blue pillow, a blue bucket, a blue pencil, a blue cup, a blue bow. Really cool. Great stuff. I bet, well, I have a blue coffee mug. That was fun. Okay, let's take a look at something else now. Shannon?
Now search your room for something shaped like a diamond. And just like before, let us know what you found in the question box. And if you want something that's a little bit more challenging, try spy something 3-dimensional, like a cube or a cylinder or a pyramid. And we're going to give you about 15 seconds.
Shannon, have you found anything diamond-shaped or 3-dimensional? And how
I actually found a 3-dimensional object, and it is a cone-shaped tree decoration.
Exciting. Rebecca and Andrea?
Well,
I
I
couldn't
found
find
this
it.
blanket, and it has a diamond shape in it.
And I couldn't find a diamond shape, but I have a nice cube for our Kleenex box holder.
Well, great job, everybody. Let's see what the girls found. Oh, that's neat. Somebody has a Rubik's Cube, a juice box, curtains, ornaments, lava lamps. Ornaments are really cool too, and lava lamp, of course. I have a diamond. But why brag? All right. Great job. Piece of paper. Yeah, keep it coming. You guys are doing awesome. You made observations. That's a really important skill that all scientists do. So, excellent job. Observation isn't just about looking at things, though, right? We also need to think about what we see. What we see are clues. We can use those clues to learn more about the world, whether we're playing a game or making a scientific discovery. Now, you can use your observation skills by seeing with your eyes, but did you know you can also make observations by using your other senses, by touching, by hearing, by tasting, by smelling. All these things come together to help you make observations. All of our senses give us different types of information. Even if one of your senses isn't as strong as the others, you can still learn a lot about the world around you. Making observations is incredibly important. Now, our EPA scientists are going to help you observe the world in different ways.
So it's pretty surprising what we can learn if we just look at the world in a different way. How would you observe the world if you were a dog? I want you to spend about 15 seconds pretending you're a dog right now, right where you are, and then let us know what you observed in the question box. So how do you look at the world as a dog? You might need to get down very low if you're a small dog. You get down low to the ground. What senses would you use as a dog? Would you use, you would look, you would smell. Let's see some of the answers coming in. You could be a big dog. So some of the dogs are seeing legs, dirt, a play ball. Maybe the dogs see other dogs, especially if they're in the dog park, and some of those dogs might be bigger or smaller. They might see their leash, water to drink. They might also see their food and treats. We know that dogs love seeing their treats. These are great answers. And maybe they'll smell some of those too. They might smell the treats if you get your treats out, or hear them. Sometimes dogs can hear the rustle of the paper. So thank you for your answers, and good job looking at the world like a dog and sensing the world as a dog.
Great. Okay, now spend 15 seconds pretending that you're a bird. Tell us what you might observe and enter that into the question box. So for a bird, maybe we're flying high above the ground, maybe we're looking down. What do you think you'd see when you were flying? What do you think you would see if you were perched on a branch or maybe sitting in your nest? Well, I think if I were flying in the sky, I might see some clouds and maybe the tops of people's heads. Oh, here's some great answers. The sun, the grass that's down below, maybe some leaves. Maybe those are on the ground. Maybe they're in the trees. Maybe they're in our nest. And we might also have eggs in our nest. Great answers, birds.
And now pretend you're a fish for a few seconds. And just like before, you're going to tell us what you observe in the question box. Now, if you're a fish, you can see underwater. So what would you see when you're swimming? What do you think you would smell? Do you think you could taste anything? If I were a fish, I would probably like to look at all of the corals and the seagrass and shells. What about you? Ooh, we have others saying that they're going to see coral and seashells. We have sand, underwater volcanoes, very cool. And salt water, definitely probably taste some salt water. Ooh, and somebody said seaweed and someone else said sharks. Wow, you You guys really observe some good stuff, little fishies.
Really good observations. So interesting to try to pretend that you're an animal and observe the world the way that they do. You can see that they use all of their senses to figure out where they can find food or even a safe place to sleep. As you make observations, try that skill too. Move in really closely to see the tiniest details in what you're looking at, and then stand way back to get a different perspective. And don't forget to use all of your senses. So thanks so much for exploring observation with us. Now we're going to hear from Rebecca, Andrea, and Shannon again about how they use observation in their work every day at the EPA. Let's start with Rebecca.
Great. Thanks, Darlene. In my work, I observe how we use energy in the United States. How do we power up all of those light bulbs, TVs, cars, and trucks? So to give you some examples, I'm going to ask you to try to observe energy. You can do this later, or you can look around you right now. So if you look around your room, we're all in different rooms. If you look around, how do you see energy being used in your home? What's plugged into the wall? Are there a lot of plugs? How many light bulbs do you have in your home? Look at the ceiling. There may be lamps. Look outside. Look in other rooms. Energy lets us do a lot of amazing things. We use it every day in many ways. We light up our home. We give power to all of our devices, and we drive our cars or ride in cars. Now think about the cars you may ride in. Are they powered by gasoline? If you've ever gone to the gas station with someone in your family, I'll bet you've also observed the smell of gas. Gas is what we call a liquid fuel, and there are many different kinds of liquid fuels. You ride a school bus or maybe a public transit bus to get around places. Buses are a lot bigger than cars, so they need a different, more powerful type of liquid fuel. That's called diesel. When we drive, diesel and gasoline can produce some air pollution. And they also can contribute to hotter than normal temperatures around the world and can make some changes in sort of the typical weather that we're used to seeing. Hurricanes may be stronger than what we've had in the past. All those changes together are called climate change. And the power plants that make the electricity we use can contribute to those climate changes. So our role is to make sure that the electricity and these other fuels, these liquid fuels and other energy that we all use every day are as clean as possible. And it's important to find ways to produce that energy while keeping our air clean and protecting that planet. So as a scientist, I try to calculate energy use for the whole country. And these are really, really big numbers. And we don't know what every single household does, but we can kind of estimate what a typical household might use, what a typical home or apartment building might use. And in my work, I not only observe and think about how we use energy right now, but I also try to think ahead to the future. In 2030 or even 2050, you might be 30 or 40 years old by now. And how will we use energy then? Might look really different. What if we didn't use gasoline for our cars, but we plugged them in to charge the battery, like we plug in our phones or our tablets or our other devices? And what if our light bulbs were able to give that same amount of light, but they used less and less electricity? And where does that electricity come from? It might come from what you know as fossil fuels. Those are things like coal and natural gas. But in the future, it might come from more of these wind turbines and solar panels that you may have heard or seen. So my job is not to just observe the present, but also to imagine the future. And I use a computer program to help me calculate all those changes and how it can hopefully improve our environment and our health. Also, if we observe how we use energy, all those light bulbs and things we switch on, we can also be a little bit more mindful about how we use them. You can take shorter showers, you can power your devices down when you're not using them, and you can turn off your TVs and game consoles when you're done with them. And you can always make sure that you turn off the lights when you leave a room. That saves energy. So thank you.
That was great, Rebecca. Thank you so much for telling us how you use observation to calculate energy use and to think about new sources of energy that can be friendlier to our planet in the future. Thank you. We'll hear from you again during the question and answer session. Let's bring back Andrea to talk about how she uses observation to study air pollution.
Hi again. As Darlene told you at the beginning of the event, my work involves observing air pollution. Now, sometimes we can observe air pollution using our eyes. Maybe you've seen the smoke from a wildfire, like the ones that we saw in California this summer. Or maybe you've seen a layer of smog across a city. Now, smog is just smoky fog, but that sounds really yucky, doesn't it? That's a kind of air pollution, and smog is a combination of particles and gases. You can think of particles like dust, just really small pieces of dust. And gases are like the fumes that come off of a car or a truck. And sometimes cars and trucks make a lot of these fumes and smoke. Those are called emissions, and they can cause air pollution too. Now, sometimes we can observe air pollution using other parts of our body. Maybe we smell it, but maybe we feel it too. So for instance, maybe we might feel our lungs burn on a red or orange air quality day. Have you ever heard of that? A red or orange air quality day just means that your city or town has issued a warning that air quality might be bad. Now, if you have asthma, maybe you've also felt air pollution because sometimes it might be harder to breathe if there's smoke in the air. But sometimes air pollution can be really hard to observe, and we need tools like air sensors to help us measure the air pollution. And that's what I work on. So air sensors are devices that can help make invisible air pollution visible by showing us a number or a color. Now, if we observe some numbers and low numbers start to get higher, we know that there's more air pollution in the air, and that's really bad for us. Sometimes a sensor might display a color, and generally green is good, and red starts to mean that it's bad. And we can use this information maybe to make changes. So in my job, I work to test air sensors and to give suggestions to people on how to make them better so that when you buy one, you can make sure that it works well. I don't want you wasting your money. Some air sensors are portable, which means that you can carry them around with you. Maybe you can hook them to your backpack and walk to school. As you see in the picture on the right, you can even wear one like on a wrist or something like that. Then, when you walk outside with it, you can learn about the air pollution in your community. By observing when the numbers go up or the colors change on your sensor, and by observing what's happening around you, you can learn what might be causing air pollution and what changes you can make to avoid it. So, for example, you might observe that the numbers are lower when you walk through a park, which means that the air is cleaner, and that's better for you. And thanks to those trees and plants, our air quality is good. And we might choose to do that instead of walking along a busy road where there are lots of cars spewing some of those unhealthy emissions, where the air pollution is bad and it's not very good for us.
Thank you so much for telling us how we can observe air pollution even when we can't see it, and for letting us know there are things that we can do to help prevent ourselves from experiencing too much air pollution. And we'll hear from you again in the question and answer session. Let's bring back Shannon, who will tell us how she uses observation to study water quality.
Hi again, everyone. So as Darlene just told you, I'm a biologist at the EPA, and part of my job is to help make sure that we have clean water to drink and to play in all across the United States. Now, sometimes there are tiny microorganisms or germs in our water that can make us sick. And I have a couple of pictures here showing you some of those microorganisms. The first one shows a group of noroviruses, and these are really, really tiny little viruses that kind of look like spiky balls. And the next microorganism I want to show you is Giardia. And Giardia is neat because when you look at it under a microscope, it looks like it has a little face smiling back at you, but it's not actually a face. And both of these germs are really tiny, much smaller than an ant or even the thickness of a single human hair. Now, most of the time, these microorganisms make our tummies hurt. So they give us diarrhea or they make us throw up, and it's no fun being sick like that, is it? Well, it's really important for EPA to know when people are getting sick from these kinds of germs in our water, because that's how we know that we need to better clean the water, for example, by adding special chemicals that can kill the germs. Or we can at least tell people not to drink or swim in the water. So how can we tell if people are getting sick from water? By using observation. So one way we do this is to look in your body for antibodies. So your body makes antibodies to protect you from invading germs. And antibodies help you get better when you're sick. Now, usually they're found in your blood, but we can also observe them in saliva or spit. And that's a good thing because it's a lot easier to collect saliva than it is blood. And we can see the saliva collection sponge in the tube that I use in my work in the picture here. It's really easy to collect a saliva sample. It's just like brushing your teeth with a sponge. So once I've collected saliva samples, I take them back to the lab, and my job is to observe the antibodies in saliva. Now, if I find certain types, that can tell me which germs in water might be making people sick. And once I know which germs are there, I can help figure out how to keep the water clean and make it safe to drink and swim in. So the work I do helps EPA make sure all of our water is clean and safe, so that we can all stay happy and healthy while we're playing at the beach, or even just something as simple as drinking a glass of water. Now, a really cool thing is that our work goes beyond observing what can make us sick from our water. And we also study germs in other parts of the environment. So we've recently just started looking for antibodies in saliva to help us understand who's getting sick with COVID. And this is all new and exciting work. So everyone stay tuned, and thanks for listening.
That was great, Shannon. Thank you so much for telling us how you making observations helps us protect our water and make sure that we're not drinking the germs that might make us sick. It was also really interesting to start to hear about the work that you're doing in COVID. So good luck with that, and thank you for sharing it. Okay, now we're at the part of our event where everybody gets to come back on screen and answer questions that you might have. So everybody back on screen. First of all, thank you to our scientists for sharing your work with us and telling us how observation helps you do your work at the EPA every day to protect us. I'd also like to thank everybody who tuned in. Thank you for listening. We're not done yet. This is an important part. Now is when you get to ask questions. Post your questions, and we'll begin to answer them. Wow, I see so many already. Let's see. Okay. From Julia in Minnesota. She wants to be a park ranger. And how does the EPA work with parks and park rangers? I don't know if one of our scientists can answer that. If not, we can move on to another question, but I bet there's a way that Julia can get an answer from the EPA. Anybody have any suggestions?
I can give an example. So for my work, I do air quality. And did you know that some of the parks actually measure air quality too? Well, we collaborate on some of that effort and share data.
And I can add a little bit too. We know that there's volunteers, citizen scientists, who also work with park rangers to collect that data and analyze that data to help answer questions that scientists can't answer alone. Okay, lots of questions that are falling into this similar one, which is, for many of the young scientists out there, I actually want to know from each of you, what is your favorite part of your job?
If I can start, I always loved math. And so for me, when I get to look at all the data and figure out what it means and do the calculations, I've always loved the math and really love the excitement when you find the answer and you're able to take all of these numbers and all of this data and find some of the answers about how we can better protect our environment. So for me, I love the math.
And for me, I also really like working with the people I work with. I work with some very talented scientists, and it's really fun to collaborate on ideas and to design projects and to talk about our data and all of the findings together.
And I'll say that probably my favorite and most rewarding part of my job is public service. I really love being a public servant and doing public health work and taking care of communities. And I will also say that I agree with Andrea. I work with some of the best and brightest and greatest people.
Excellent. Okay, and for all three of you, two more questions. One is, what is it like to work in the lab? And then also, if you can tell us a little bit about advice that you would give your former 8-year-old self, knowing what you know now about science.
So I can start with the lab question. My lab is a little bit different. I can do lab work in a traditional lab that's like in my office, where we have chambers, so like a big structure where we put in some sensors and we try to understand how they work by pumping in some gases and things like that. But my real lab is actually outdoors. So we set up a lot of these sensors outside and we try to understand how they work and what might influence them. So inside and outside work, very cool.
And if I can add to that, my team that I work with, we also measure things indoors and outdoors. And so sometimes when we're measuring the emissions that come off of a car or a truck, sometimes we measure them inside of the building and they're on a wheel that turns and the vehicle is running, but it's not actually going anywhere. So we can kind of connect all the equipment to it and measure the emissions. But sometimes we want to also see how the emissions happen when they're on the road. And so sometimes we'll also be following the vehicles on the road, taking air pollution samples and trying to figure out their air pollution from the.
And I also work in a lab, and what I do is more in what we call a wet lab. So I actually am at a bench with lots of instruments and technical equipment and wearing my gloves and my lab coat. And I have to say, sometimes it can be pretty gross working with saliva and spit samples. But sometimes it can be a lot of fun to get the data and do all of the math, like Rebecca was saying. And if I had any advice for my 8-year-old self, I would say to be patient with myself as I figure out what I love to do, because I think 8-year-old Shannon had lots of big, great ideas, and it's taken me a good long while to really find what it is that I love and am passionate about, and really happy to be serving at the EPA.
And if I were to add something, a piece of advice for my 8-year-old self, I think it would be to talk to people about what's exciting to me and what I think I want to do when I grow up. And I think that it's really important as you grow up to take opportunities to try something out. So you'll learn what you're good at and what you really want to do when you grow up. So that means like volunteering and trying things out.
And I would add to that, and I would say a lot of the work and people that I do and people that I work with are not only engineers, but not only scientists, but engineers. And growing up, when I was an 8-year-old, I didn't really know what an engineer was. I loved physics, and so I decided to do physics, but I probably would have loved to be an engineer and maybe followed that path more. So there's different ways to do science and different paths to get there. So I would just also say explore the different ways that you can go in the different careers for science.
Those are great answers. I think at 8, I was just tap dancing and wanting to be a cheerleader and thinking of all kinds of things, but also staying curious. I think that's a big one too. Stay curious and remember that everything isn't answered. A lot is left to be discovered. I learned that very late. Okay, I want to thank our scientists for joining us. I want to thank you all for your great questions that you've been sending in. And I think we've learned a lot about making observations and how those observation skills are really important in science. I hope you've had as much fun as we've had in learning about observations, learning about science, learning about what scientists at the EPA do, and then also getting started with your Think Like a Citizen Scientist journey. Did you know you just got started on that? If you want to continue, you can. And if you go to the Girl Scouts store, you'll find the Think Like a Citizen Scientist journey materials, protocols, activities. All of it is for free. All of it is downloadable. And there's lots of ways that you can learn how to think like a citizen scientist, how to make those observation skills work for you, and how to take action to complete your journey. You can jot down that link right now, and it's also in the Do More tab and on the Event Resources tab. I think that'll all make sense when you're on the Girl Scouts store website. Now remember what we talked about at the beginning of the event, that you can get a free EPA 50th anniversary patch. Well, if you watched and stayed with us to the end of this event, live or through a recording, Now's your chance to get that badge. You're going to stay and take a survey. You'll see a link pop up as soon as this event ends. That survey will also include a special code and a link. That link is to the Girl Scout shop, and it will appear on your screen. Make sure that you enter the code to get your free patch. And I'm just seeing notes here that some folks are saying the link leading to the page is not working, so just be a little patient. I bet my friends will fix that quickly. Patch supplies are limited, so don't wait to order yours. They'll be shipped out starting in early to mid-January. And you can find more details under the Do More tab and in the event resources handout. Hopefully they work. Okay. All right, everybody. Thank you so much for joining us today. We hope that our time together has reminded you about the importance of making observations and has inspired you to go ahead and get started with your Think Like a Citizen Scientist journey. Thank you so much to EPA Administrator Andrew Wheeler and the EPA for their support of this important program. And of course, to our EPA scientists, Rebecca, Andrea, and Shannon, for sharing their time with us today. Thank you so much, everybody, for joining us. Go out there, become citizen scientists, and you can change the world. Thank you, everybody. Goodbye.